Key features of rational functions. All right, we're going to look at some key features that include holes, vertical asymptotes, the end behavior, and horizontal asymptotes. These are new key features of functions we've not yet discussed. So those are going to be the four that I'm going to focus in on. All right, so in a previous video, we looked at how do we determine holes and vertical asymptotes from the equation. And one of the things that we discussed was that the vertical asymptotes and the holes are found in the denominator of the function. Okay, and that's because we cannot divide by 0. So I have to ask myself, well, if I look at x minus 2, what number do I put in for x to make it a 0? Well, that is x equals to 2. And what number do I put in x plus 3 in order to make that equal to 0? That is x equals to negative 3. And because if we cannot put 2 or negative 3, these are what we're going to call our excluded values. We cannot use those values because it makes us divide by 0, and that's impossible. So what I'm going to do now is I am going to trace over to x equals 2. And when we trace over to x equals 2, we're going to see if it is a hole or a vertical asymptote. And you'll notice right here, boom, it is a hole. It says undefined, and on the graph, it has a circle that is hollow. There's nothing in there. That means that is simply a hole. So I'm going to say the holes are at 2. Okay, so hole is at 2. Okay, and one way we can determine that if it is a hole, if you remember from a previous video, is that holes cancel completely out in the denominator. So that x minus 2 cancels with the other x minus 2, making the x minus 2 completely disappear in the denominator. Okay, vertical asymptotes are a little bit different. Vertical asymptotes are an exact distinct break. It is a distinct break in the graph. Okay, and what you'll notice is there's a part of graph here and there's a part of graph here, and they do not connect. Well, that's also found in the denominator. So I have to go to this other value of x equals negative 3. Check it out. If I go to negative 3 and I graph a line straight up and down, it looks like the graph is kind of approaching in that direction. Okay, but it's never going to actually cross that. Okay, so that is what our vertical asymptote is. It's vertical because it's straight up and down. It's an asymptote because it's a place where the graph is approaching but won't get to. Okay, so our vertical asymptote is x equals negative 3. Now, with that being said, one way you can determine if it is a vertical asymptote is that it does not go away in the denominator. It does not cancel out in the denominator. So that x plus 3 is going to remain there. Okay. Now the end behavior, we've talked about that before. End behavior is where does it level off? And remember, as we do end behavior, we start saying as x approaches infinity, what does f of x do? What does the graph do? Or x approaches negative infinity. What does f of x do? Okay, well, let's go out to infinity. Let's do that. If I keep going out here, guess what? Check out what's happening. That graph is getting lower and lower and lower, but guess what? As I trace that graph down, look at the y value. All it is doing is getting closer and closer to a y value of 0. So as we approach infinity, f of x equals or approaches 0. Okay. So it is approaching 0. Okay, now let's go to the other side. We got to go all the way out to negative infinity. Let's go all the way out to negative infinity. Let's go all the way out to negative infinity and check it out. It is doing the exact same thing. It's not going to cross. So we are going to say that as x goes out to infinity, the graph is approaching 0. Okay, that is actually pretty cool because that leads us to our next thing, which is what we would call our horizontal asymptote. Okay, and when we talk about the horizontal asymptote, what I want you to think is across. Vertical was up and down, horizontal is across. And If I draw a line across, it is another thing, asymptote, a distinct break in the graph. Okay, so we could write that down. Okay, distinct break. Okay, but we are no longer looking at it vertically, we're looking at it horizontally. And look at, here's a distinct break in the graph right there at y equals to 0. So my horizontal asymptote is going to be y equals to 0. Now I know those are a couple new key features of functions, but they are easy if we really break them down, look at them into the graph, and understand some of those concepts of vertical asymptotes, holes in the function. Y'all have a great day. Hope this helps.